So for number 3, who's paying attention to this? Who am I talking to right now? Okay. 4 people. For number 3, it says, let A be the area of a square whose sides have length x, and assume that x varies with time t. So, part A says draw a picture. This should be easy, because you're just drawing a square. It says it's a square, so you draw a square. You know, I didn't know that on Sandlot, where he says L7, it's a square. L7. It's actually a rectangle.
Well, I don't get it still.
Like when you say you're a square,
Oh.
like you're a square, like you're a nerd or you're like out of place or something. L7, it's a square.
Yes, like both at the same time.
Alright, so that's part A. Draw a picture with labels A. So I'm going to say A is the area in the middle, and then X is just all of the side lengths, because it's a square. Part B, write an equation that relates A and X. If we're thinking about the area, then it's just area of a square is side squared, so part B is just A equals X squared. Are we okay? We're okay, right?
Okay, but the majority of the time.
You guys should whisper. Okay. Use the equation to find an equation that relates dA dt and dx dt. All that means is take the derivative of this. Here we have to use the power rule and implicit differentiation. Here we have to just use implicit differentiation. Derivative of A, like normal, is just 1. And you tack on a dA dt. Remember, we're taking the derivative with respect to time. And then this would be 2x. And then tack on a dx dt. So that's part C. That's C there. D is at a certain instant, the sides are 3 feet long and increasing at a rate of 2 feet per minute. How fast is the area increasing at that instant? So what I want to write down are the rates and what they mean. So they're saying, well, I have dx dt. That's rate at which x is increasing. We know it's growing because it says it's increasing. Rate at which x increases. Since it's increasing, it's going to be positive. And dA dt, rate at which the area changes. And this is also going to be positive because the sides are getting bigger and bigger, the area is getting bigger and bigger. And now I'm going to say dx dt. We had dx dt, right? Is that true? What is dx dt? It's 2 feet per minute. And they want us to find how fast the area is increasing. They want us to find dA dt. What's the thing that we have to include after this? When what? So when the when part, when what? When x equals 3 feet. Well, we already have an equation to relate the rates. So we're just plug in what we have. That's dA is, I don't know, dA dt. 2 times the 3 feet times 2 feet per minute. That's feet squared per minute. That's right. It's feet squared because you have feet times feet per minute. So it's feet squared also still per minute. Or you can just think, oh, it's area, so it's gotta be feet square per minute. You can stop now.